All right, morning, happy Tuesday. First things first, I'm gonna announce it here. I wanna do a quiz, just a quick quiz again on chapter 4 stuff on Thursday. So quiz number, I feel like we've done more, but scrolling through our Moodle, it looks like we've only done 2 quizzes. So time for another quiz. Quiz number 3 on Thursday this week. And it's going to be on chapter 4. On chapter 4, which we'll finish today. Which we will finish today. Right, same thing, it'll be open kind of all day on Thursday. Quiz will be open all day on Thursday. Okay. But, and then we'll use the first 20 minutes of class if you want to do the quiz then. And first 20 minutes of class will be designated to writing the quiz. To writing the quiz if you want to. All right, so you can use those first 20 minutes for the quiz if you want to, or not, doesn't matter to me. And then class will start 10:20, I guess. Same setup as the other 2 quizzes. So the reason I want to do a quiz is because we've got our test, our second test coming up on next Thursday. So test number 2 on Thursday, March 18th, day after St. Patrick's Day, my calendar says. So, and of course, test 2 is gonna check up on chapter 4 and chapter 5. So we haven't started chapter 5 yet, but I think what you'll find is once we've kind of introduced everything in chapter 4, we just do it all over again with just slightly different formulas. Okay, so test number 2 is on chapter 4 and 5. Okay, so that's why I want to do a quiz, just to make sure that we're all caught up on chapter 4, and then we can kind of start fresh into chapter 5, which will go kind of quickly because we've already seen all the scenarios in chapter 4. Okay, so and then assignment 5 is due on Thursday this week. Assignment 5 due on Thursday, March 11th this week, right, which conveniently would prepare you for quiz 3, right? Test 2, quiz 3, and assignment 5. Ugh, that's going to get confusing. So of course, assignment 5 will prepare you for the quiz, so it might be a good idea to do the assignment first, then attempt the quiz, but what do I know? Okay, so we were working on a big mumbo jumbo of a question here last day, and we did not have time to finish it. So of course, that's what we're gonna start with today. And I'm just gonna grab it all, try to at least copy. And last day. So let me know if you have any questions about quizzes, assignments, tests, maybe in the chat. I'm keeping an eye, but pretty quiet there. So from last day, okay, we were working on this huge problem. Let me just paste it in. So this scenario, right? So let's just kind of wrap our heads around the scenario again. So somebody borrows money from someone else, okay? And they have this original repayment plan. And then what's going to happen in all of these questions, or typically kind of the hardest type of question we can do is right here. And then they change their mind and they're going to do a new repayment schedule. So what we want to do is we want to map out the original payment schedule, and we want to make sure that the new payment schedule or new repayment schedule is equivalent to the old one, right? And so that's going to take practice for sure, right? Being able to map these things out. And then we're using equivalent payments, right? So for example, we found that $500 4 months ago ended up being worth $518.75 in 1 month from now, right? Those are equivalent payments, okay? And so now we're just extending it to kind of a multiple repayment scheme. And it's not until you've read a lot of these questions that you'll start picking up on, oh, okay, I know what I need to do for this question because I've seen this type of question so much, right? But this is kind of the hardest type of question that I'm going to get you to do for simple interest. And that is, okay, so 4 months ago, so I'll just read the question just so we can remember what it was. So 4 months ago, Teresa borrowed $1,000 from Josh and agreed to repay the loan, trying to combine words here, in 2 payments to be made 5 and 10 months after the date of the agreement. So what we did was we said, okay, well, here we are today, and we're talking about 4 months ago, but then 4 months ago, they agreed to repay this 5 and then 10 months ago. So we mapped out this timeline. That's hard, right? When you're reading this question and you're trying to figure out what your timeline looks like, that is hard. You'll need to practice that, okay? One thing that I do is if I'm having a hard time, sometimes what I'll do is I'll just list all the time points that are of interest. I'll list them on the side and then I order them, right? Because then we had to figure out, okay, so each payment is to consist of $500 of principal and interest at the rate of 9% on that 500. So we split that $1,000 into 2 $500 bills, let's call it. Today, Teresa is asking Josh to accept. So now she's suggesting a new repayment scheme. Okay, so today Teresa is asking Josh to accept a single payment 3 months from now. So we had to map out the 3 months, okay, to settle the debt. Okay. So what payment should Josh require if money can now earn 7%? So now our interest rate has changed. So what we need to do is we need to figure out the values of the repayments with the original repayment scheme, which we did last day, right? We found that this was $518.75 and this future value is $537.50. So we know how much she would have had to repay in the original repayment scheme. Now what we want to do is we need to figure out, okay, well, what are these dollar amounts worth in 3 months from now, right? So basically she needs to take out a new loan on future value 1, right? So future value 1 has to get moved to 3 months, but also she's paying off future value 2 sooner than expected, so she should have to pay a little bit less in interest, right, if she's pulling it back to 3 months. Okay, so what we need to do is we need to make sure that the new payment scheme is equivalent to the original repayment scheme. So here, now we need to make sure the new repayment scheme is equivalent, to the original repayment scheme. So what I'm going to do is sometimes I will put this all on the same timeline, and then sometimes I'll just do a fresh timeline. In this case, because we're kind of starting the day off with this, I'm going to do a fresh timeline. But I do have all these time points already laid out. In fact, I also have these future value amounts. So I'm going to put those in and exclude this old stuff. This is from the old repayment scheme, right? And so now I'm going to draw up my new repayment scheme. So I have my timeline, and just like I had 3 months on here before, oh, sorry, it's lagging. I had 3 months on here before. I didn't end up using it because it's part of my new repayment scheme. I'm also going to keep the 4 months ago, even though it's not really part of the equation, but I want them to be able to kind of transpose onto each other, right? So just to kind of, it's not transpose. When you put one thing on another thing, maybe it's transpose though. I'm thinking about matrices. Anyways, I want to be able to, in theory, take my new timeline and just be able to place it on top of the old one, and it should still match up. Okay, can't think of the word right now. So I had 4 months ago. I had today. And then I was talking about 1 month and, sorry, it's really slow today. 1 month, 3 month, and 6 month mark. 1 month from today, 3 months from today, and 6 months from today. Yeah. So, okay, just like we found earlier, right, with our original repayment scheme, we said, okay, well, $500 4 months ago is worth $518.75 in 1 month from now, right? $500 4 months ago is worth $537.50 6 months from now. So from now, or if you want to talk about in terms of the agreement date, that's fine too, but I'm just going to talk about from now because that's what my timeline is. So now I have dollar amounts here, and I want to make sure that, okay, well, if this was what she was supposed to repay, then her new repayments should be worth the same amount, right? And so now I am going to put in the dollar amounts here. And so I have, right, and remember we put the dollar amounts underneath the time points. So I have $518.75. And here she was going to repay $537.50. So that's what she was supposed to pay. But now what's happening? Now she wants to repay 3 months from today. So she wants to repay at this point here. So here, this is our new repayment date. Okay. So kind of visually, what's happening then? Well, that means that this 518.75 has to get pulled forward, right? So if I'm pulling it forward because I'm borrowing it some more, right? So she's borrowing it for a length of 2 months, right? You don't want to get tripped up with the right? You want to look at the distance between 1 month and 3 months. So she's borrowing this for 2 months. So she has to pay a little bit more interest on it, right, for 2 months. The interest rate has changed to 7% now, so we need to remember that. Okay, and so here, this is going to become a future value, right? If I'm pulling some dollar amount forward, the amount on the right-hand side is always my future value. Okay, and I know that is going to be tricky for a long time now, but the more you kind of tell yourself, okay, so here 518.75, that's my present value or my principal amount, and it's getting pulled forward to a future value. I'm going to call this future value 3 because I've actually already used future value 1 and future value 2. So I don't want to confuse myself. I'm going to call this a future value 3. Notice, and this is where it gets a little bit dicey, right, is this 518.75 was itself a future value. But in this relationship, right, where I'm borrowing 518.75 again and pulling it to a future value, in this relationship, the 518 is the principal amount, right? So just keep those straight. So I'm going to call this future value 3, just so there's no confusion. And then, but I'm paying off this 537 early. So 537.50 would have been my future value, so I need to pull it back to 3 months. So if I'm pulling it back, what I'm finding is a principal amount. For my subscripts, I'm going to use 4, mainly to denote that this is my 4th calculation. You could use 1 if you want to use kind of different subscripts for different things, but I use the subscripts to denote my calculations rather than anything else, right? So I'm going to use P4. This is my 4th calculation. Now, the total, right? So she said, hey, okay, in 3 months from now, instead of our original repayment, okay, just forget it. Okay, I'm gonna just pay you one lump sum 3 months from today. Okay, so what she's proposing is that her new repayment scheme would be the total of future value 3 and principal 4. So this is the new single payment. And that's what we're trying to find, right? So this is our new repayment scheme. We're not quite done with our timeline because remember on the arrow, we want to put the amount of time, right, for each and the rate, right? The rate for each of these is the same. It's at 7%, right? But if you had these on the same graph, right? So if you took one of the timelines and placed it on top of the other one, you would need to keep track of the different rates, right? So now we're moving to 7%. So I want to put that on there. Right? So the rate is 0.07 for each of these. And then just try to keep it straight in your mind, right? That the time is the amount of time that the arrow spans, right? So between 1 month and 3 months, we've got 2 months. Time has to be in years. So then T is 2/12. Between 3 months and 6 months, I'm traveling 3 months in time, right? So time is 3/12. Okay. So now I have all this information. Oh, hey, what's going on? Sorry. I don't know what my computer just did, but I'm back. Okay. Everything went away. Who knows? So this, right, I highlighted before, right? This was our original repayment scheme, so I'm going to do the same thing with the new one. And so this is my new repayment scheme. So why couldn't we just take the 500, right? The 500 from 4 months ago, why couldn't we just pull it to 3 months? Because the interest rate changed, right? So we need to be able to capture that. And so there are a few different ways that you will be able to solve this problem, but for now, this is probably the most solid way. It's kind of the most dependable way, and the way that I would expect you to solve this problem. Later in the next section, I'm going to show you how to deal with changing interest rates. So you will be able to deal with it, and then you could use that. But for now, and for solving these problems in general, this is how I want you to do it, right? So just figure out the old repayment scheme and then the new repayment scheme. Okay, so let's solve for future value 3. So it's been a little while, right? So let's say we know the future value is P times 1 plus R times T. And P becomes the future value over 1 plus RT. So what I'm going to do, I'm going to do these calculations side by side, right? I need to find future value 3 and I need to find P4. So the future value 3 is the principal amount of future value 3 is $518.75. So P is $518.75 times 1 plus R, which is 0.07 now, and T, which is 2/12. Oh yeah, so when you draw this timeline, you don't need to include this stuff here. It might be nice to have today on there as a reference point. So you don't need to have this on here. But the reason I'm doing it to match is so that I could take it and put it on top. And I'll draw them combined when we're done the problem, just so you can see what it would look like. So you don't have to, but it makes it easier to read later on. But it does make you cramped for space, so I get it. Okay, so solving this, I'm just going to do it on my calculator on the side here because, well, my calculator has adds, so that's annoying. 2/12 times 0.07. Okay, so just remember you have to do this section first, right? And to show that, I show that in my work by going 518.75 times 1 plus 0.01166 repeating. You don't have to show that step if you just went straight to adding 1 and then times 518.75, that's totally fine. 524.8020833, which in monies is 524.80. I'm gonna scoot this over because I didn't really give myself a ton of room for my P calculation later. Okay. Just do a mental check, right? Your future value should always be larger than the principal amount, right? So the principal was 518, it grew to 524. That makes sense. If you invest money, if you invest $518.75 at an interest rate of 7%, you would expect it to grow, right? And so just kind of have that as a check-in point that P is always less than the future value, regardless of if you're borrowing money or if you're saving money, right? Depositing money. So to find P4, right? Well, now my future value of P is 537.50, right? So I have my future value and I want to know what is it at this time point, P4. So P4 is 537.50 divided by 1 plus R, which is 0.07 in this case, times T, which is 3/12. Okay, so same thing, right? I want to simplify the 0.07 times 3/12, then add it to 1, and then divide 537.50 by that. Okay. So I'm going to simplify this and say P4 is 537.50. And again, if you wanted to skip straight to the final number, that's fine. Make sure you round properly. 0.07 times 3 divided by 12 is 0.0175, which is 1.0175. Oops. I lost it. 0.07 times 3 divided by 12 plus 1. Then 537.50 divided by that guy. Make sure that you get P4 equals 528.2555. 528.2555.283. Sounds like a phone number. A fun phone number. So P4 in dollars is 528.26. Okay. Always ask yourself, does that make sense? Does what I'm saying, does it make sense? Right? Well, it means I used to owe 537, but now I'm repaying it a little bit early. So it makes sense that I'm repaying a little bit less, 528.26. So the total new single payment that she's proposing has to be the sum of these two, right? So our new single payment is future value 3 plus P4, which is going to be 524.80 plus 528.26. Just adding those up. I get 1,053.06. Those repayment schemes, even incorporating the change in the rate, are equivalent, right? And so now what we've found is that her paying $1,053.06 3 months from now is the same as her paying $518.75 1 month from now and $537.50 6 months from now, right? So these are the same, and that's where we get these equivalent payments from. Good. Okay, so those are tricky. We could draw, so like I said, we could draw all these on the same timeline, and often it is what I will do just because I'm a little bit lazy and I don't want to draw a timeline twice. So, well, this is the answer here. We could draw both repayment schemes on the same timeline. What does that look like? Okay, so I'm going to draw my timeline once more, and then I'll let you decide which you like best. If you want to break them up, I'm just going to deal with one and then the other, or if you like having them all on the same one and just kind of seeing the connections, that's fine too. You just got to see what you like. So I remember I needed 5 time points here. So I've got 4 months ago. I've already done the work for this, right? Trying to figure out what these time points are. So 4 months ago today, 1 month from today, 3 months from today, and 6 months from today. And we said, okay, well, this distance is, and I'm going to keep it on the same page here. This was 5 months. And this distance here is 10 months. That's from the original question. Okay. Sorry, I got your message. Do you mean dollars to dollars? Oh, that's because the interest rate has changed and also the time points have changed. So the dollar amounts will never be the same, but to Josh, or I can't remember the name of, yeah, she's borrowing from Josh. To Josh, these dollar amounts are equivalent, right? Because what's happened, and I think it'll be easier to see if I map it out. So let's just map it out here. Yeah, so the dollar amounts will not be the same, right? But economically, they will be equivalent, taking into account the amount of time and interest. So the original loan was broken up into $500 and $500 for a total of $1,000 loan. And then what we said was, okay, this has to be repaid, and they decided, okay, she's going to repay some future value 1 in 5 months. Okay, so here the rate was 0.09 and T was 5/12, so 5 months of the year. Then, so here, just kind of breaking it down, right, we found that this future value 1 became $518.75. Yeah. So this here we found was $518.75. Okay. So what we're saying is that 4 months ago, $500 4 months ago is equivalent, economically equivalent to $518.75 1 month ago, 1 month from now, sorry. Could find 1 month ago, but we're not. 1 month from now. Okay? And so these dollar amounts are different, but that's the time value of money, and that's the whole point of this course, right? And so, and this is our first time that we're seeing it, so I mean, take a beat to kind of think about it. But so this second 500 grew to some future value 2, which we found was $537.50. Right, so we calculated those. And the rate for this one was still 9%, and the time here was 10/12, right, the length of that arrow. Then we said, okay, so now she changed her mind. Here we are, we're today, and she changed her mind. She says, oh, no, I'm just gonna pay it all off 3 months from today, okay? But then the interest rate changed, and so now we're at 7%, okay? So these guys, and I'm just gonna use the same color even though it kind of goes against what I like. So this future value 1 needs to get pulled forward, okay? So it's going to become future value 3, and that's what so this is, now we're transitioning to our new repayment scheme. Same thing with, okay, well, she was gonna repay $537.50, but now she's repaying it early, so I need to discount it back to 3 months from now. And so this needs to get pulled back to some P4. And then this is our new single repayment. Remembering to put the rate and the time on the arrows, right? So the rate here was 0.07, that's different, right? And so I'm gonna jot that down on both of these. And then the time for the first one was 2/12, and the time here was 3/12, right? We already did that, so I'm just kind of jotting it all down. I also found dollar amounts here, right, which we can put in if you want to, in terms of your timeline. The green dollar amounts are totally optional. I find that it helps me visualize, but if you're able to just talk about future value 1, future value 2, future value 3, and P4, that's great. Okay, but we also found dollar amounts for these. So let's see here, it became $524.80. And P4 was $528.26. So then the single repayment we found was $1,053.06. I will say here, note dollar amounts in green are optional for a complete timeline. Okay. So make sure that your timelines are looking really good. So for the quiz, I'm not going to look at timelines, but for the test 2, I will be looking at timelines. Well, test 2, test 3, and the final, I will be looking at your timelines to make sure that your timelines are really good. So I will need to see really good, nice timelines. Okay. So this would be a complete timeline. Everything is on here, right? Even the stuff that I calculated. Okay. Big question, right? So after everything's said and done, after the dust settles, how much does she pay in interest? Well, she'll have paid $53.06 in interest because originally she just borrowed $1,000, but she has to repay $1,053.06. Easy math there. Even I can do it. Okay, good. Let's do another example. And I can't remember what. Yeah, let's do example 165. So it's very similar. I guess that's kind of the end. We didn't really do a review, so I'm not going to call it a review, but that's the end of that problem. In fact, the problem ended here once we had found the dollar amount, right, the new single repayment. But I just wanted to show you the timeline, just all in one place. All right. So now it is similar, but now what we're doing is going to be a little bit weird. Okay, so it's kind of the last type of problem that we can deal with. That's kind of big and hard. So a loan of $10,000 requires 3 equal payments to repay the debt. So here I'm talking about 3 equal payments. Okay, and that's harder than it sounds, right? Because so now the first payment is after 6 months. Okay, the second is after 1 year, and the third is after 1.5 years. Okay. So what is the amount of the payments? So now I'm solving for payment amounts. Okay. The reason that's hard is because you can't just take 10,000 and divide it by 3, because the amount of interest that you owe after 6 months is a lot different than the amount of interest after a year and a year and a half. So we need to take that into account. Okay, so the hitch here, or the glitch maybe, is that it has to be 3 equal payments. Okay. So what this looks like, I'm going to use these, the payments, I'm going to denote by just X. And then I'm going to have to solve for X. So I'm going to map this out. Okay, and see what happens. Okay, so first thing, if you don't know where to start with a timeline, figure out what your time points are. Okay, so the first repayment is after 6 months, and then after a year, and after 1.5 years. So it also mentions use today as the focal date. Okay, it doesn't have to say that, it's meant there to kind of help you along. So then you have to have today on your timeline, which you probably would anyways if you're talking about 6 months, a year, and a year and a half. It's hard to just put those on a timeline without a reference point. So and then we've got a rate of interest of 6%. Okay, and it doesn't seem to be changing or anything, so it's 6% across the board. That's good. So I have 4 time points that I want to have on my timeline. So the first thing I'm going to do is I'm going to draw the longest line I can on my page here, and then break it up into 4 sections, and then go from there. So figure out how many time points you have. Right? If I have 4, then I need to break it up and have 4 ticks. If fact, I'm going to leave a little bit of room above. So I can maybe write stuff above. Okay. Remembering that the spacing of these ticks or the time points doesn't matter. In this case, they are equivalent, but in general, right, they won't be. So here, right, just put them so you can visualize it, right? It doesn't have to be spot on. So here I am today. And then I was talking about 6 months from today, 1 year from today, and 1.5 years from today. Okay. So here, solve for the payment amount, which is different from what we have been doing. Right? So how are we gonna solve this? Well, I don't know what these equal payments have to be, right? But I know they have to be equal, so I can just use X as my payment amount. So at 6 months, I'm going to pay X. At 1 year, I'm going to pay X. And at 1.5 years, I'm going to pay X. Okay, and I'm trying to solve for what that amount is. Okay. Now, what's important is that I'm borrowing $10,000 today, right? And so today I'm borrowing $10,000. And so each of these present values, right? The present value of this X in 6 months, plus the present value of X 1 year from now, plus the present value of X 1.5 years from now, all those have to add up to 10,000 because that's my loan amount. Okay, so what happens here is this first X gets pulled back to some principal amount 1. Same thing with that second X. Remember, those X are the same, so I don't need to use subscripts or anything because they're equal payment amounts. All of these have to add up to 10,000. I'll just make a note here that this is the total loan amount. And just to clarify, you don't have to have it on there. Helps though. Okay. Okay. What do we need to put on these arrows? Well, I need to definitely put the time for each of these in years, right? 1 year, 1.5 years, that's easy enough, right? 6 months, also pretty easy, I would say, 0.5. The rate is 6% for all of these. So what I'm gonna do, just to keep it a little bit tidier, is I am just gonna write that the rate is 0.06 for all. Okay, you could put it on each individual arrow. That's fine. That's great. But just to make it less cluttered, I'm just going to put it over to the side. Okay, so now T1 corresponds to P1 is 0.5, right? 6/12, or you could use 6/12 if you want. T2 is 1 and T3 is 1.5. Okie dokie, artichoke. Now what? Well, all right, let's see what we get here. So I have R and I have T. I sort of have each of these future values, right? Each of these are on the right hand, so each of these X's are on the right hand side of the arrow, and so those are future values. But because the arrow is pointing towards P, I'm trying to find the principal amounts. But I also know that these principal amounts have to add to 10,000. Okay? And so what we're going to do is we're just going to go ahead and pretend that we know what x is. We're just going to use x as a number. So P1 is the future value over 1 plus r times T1. Or maybe what I should do is, let's just do, I'll just write it out in general, just because I've got a page break here. And then what I'm going to do is I'm going to do each of these calculations side by side, and then I'll have all the numbers kind of available. So P1, scooting it all the way over because I need to squeeze 3 of these side by side, is going to be x over 1, oops, write the 1 plus 0.06 times 0.5. Here, I'll make a note that the future value is x for all. And the r is 0.06 for all. Right? The only thing that's changing is the amount of time. Yeah? So what happens? Now, you did have to do some of these at the very beginning of the course, and this is the reason, but they were a little bit tricky. So, so let's just kind of take our time here. So 0.06 times 0.5, I have to do that first, and then I have to add it to 1, okay? So I'll just do 0.06 times 0.5 is 0.03. So this is x over 1.03. That's good, I'm on the right track here. But what I want to do is I want to have something times x. And this, it's kind of hard to see when you have x over 1.03. So, but remember that this becomes 1 over 1.03 times x. Okay, so this becomes 1 over 1.03 times x. So you've got a couple of options, and I'll go to our calculator here. Where is it? There. Affordable family living. Okay. So I'm going to clear this out here. Okay. And so notice that you've got a 1 over x button. If you go over to the right hand side here, you've got a 1 over x. Okay. What it means is whatever you have on the screen, it'll just do 1 over that. Okay, so for example, oops, if I have 2 on the screen and I hit the 1 over x button, it becomes 1 over 2, right? And so if you have 1.03 on the screen and you hit the 1 over x button, it'll just do 1 over 1.03, okay? And so 1 divided by 1.03, you can do it by hand, equals. Makes sense that you get kind of a decimal less than 1, right? 1 divided by something more than 1 should be slightly less than 1. Okay, you're going to want to store this, store it, and I'm going to store it in 1 because it's for my P1, and we're going to use it later, and you want to make sure that you keep all your decimal places. Okay, so if you try 1.03 on the screen and then hit the 1 over x button, you do end up at the same place. And you can check that. How can you check that? If it's the same as what we just stored in 1, well, I can do minus recall 1 should be 0, and it is, right? So they're the same, right? That's a quick way you can check if things are the same. Subtract them from each other, should end up at 0. So we've stored 1 over 1.03 in 1. So let's do the same for the other 2 that we need to have as well. Oops. Okay, so this becomes 0.97 x, and what I'm going to make a note here is that I stored this in 1. That's more a note to myself, but also a note to you that you have to keep all your decimal places, right? So we must keep all decimal places. Right? So you can store it is probably the easiest way. Okay. So now let's do the same thing. So what we found is that P1 is 0.97 blah, 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 blah times X. Makes sense because 0.97X is slightly less than X, right? So far things are checking out. We do the same thing for P2 and P3. And so we find that P2 is X over 1 plus 0.06 times 1, which is X over 1.06, which let's just emphasize that that's 1 over 1.06 X. Okay. Do that on my calculator here. 1.6, I'm going to use the 1 over X button. Why not? 0.94-ish, right? Makes sense that it's less than the first one because it's even further out, right? It's a year versus 6 months. So I'm going to store this in 2. I'm going to jot it down. So this becomes 0.94 ... X. And just make a note that I've stored this in 2. Now do the same thing for the last one. P3 is X over 1 plus 0.06 times 1.5. 0.06 times 1.5 is 0.09. So it's X over 1.09, which if you want to visualize it, you can. If you want to go straight to from X over 1.06, for example, to 0.94X, that's fine. Okay. But I just want to emphasize what we're doing here because it can be really tricky, right? I know people have a hard time. 1 over 1.09, okay, so now 1.09, 1 over that is 0.91743, I can't stop. So 0.91 continuing, right? And so I want to store this in 3, or wherever you'd like, but 3 seems like a good option. 0.91 ... times X. Just making a note that I stored this in 3. Okay. So good. Remembering that we're trying to solve for X. Okay. And so what do we need, right? One thing I do want to mention before I get too carried away here is, what if you had a payment here at today, right? So you do your first payment today and then you have all these payments, okay? Then you would have just an X here today. X plus P1 plus P2 plus P3 has to equal 10,000, right? And so that X hasn't moved anything, but you still need to incorporate it, right? I only mention that because it comes up sometimes, right? Where you just have a payment that hasn't moved. Oops. So now, but back to our question. P1 plus P2 plus P3 has to equal 10,000. Okay. So we know that 10,000 has to equal P1 plus, P subscript 1, I should say, plus P2 plus P3. yeah, in that case, you would have 4 payments if you had a payment today, which we don't in this situation, but then you would have, so just, I'm gonna erase this, right? But in the scenario that I just mentioned, where you would have a payment today, you would have 10,000 is X plus P1 plus P2 plus P3. So it changed slightly. Not for now, though. All right. So remembering to keep all your decimal places, right? When you replace P1 with 0.97x, you're really replacing it with store 1 times x. So this becomes 0.97 ... x. I'm doing the ... to emphasize that it keeps going, plus 0.94 ... x plus 0.91 ... x. I've got a common multiple of x. So what I'm going to do is I'm just going to factor out that common multiple of x and find that I have x times 0.97 ... plus 0.94 ... plus 0.91 ... This is the same as x times store 1 plus store 2 plus store 3. And if you wanted to skip straight to the stores, that's fine. But I just like to be able to see what they would be. So 0.97 plus 0.94 plus 0.91, just to give me an idea of what a reasonable result would be, right? It should be close to 3, but not quite 3, because all of these are close to 1, but not quite. Right? So what do I end up with? If I do recall 1 plus recall 2 plus recall 3 equals, I get 2.83170120.5. I'm going to write all those down. In fact, I'm going to store it in 4. Store it wherever you want, but I'm going to store it in 4 because I'm going to need it. So this becomes x times 2.8. Now I can't remember. 83, and it keeps going, which I have, stored in 4. Notice that this whole time, all of this has equaled 10,000. So now I'm ready to jump back into the 10,000. You can write it all the way down, but sometimes I'll just leave it off. If nothing's changing, don't bring it back in until I'm ready to use it, right? So sometimes I'll just leave it open, and that just shows that nothing's happening. Keeps it a little bit cleaner too, right? So now 10,000 is x times 2.83. So what I need to do to solve x, which is that one equal payment that I'm doing 3 times over, right? That's what I've forced, okay? And so this x here, to solve for it, I need to divide by store 4 on both sides. So here I'm going to do that switcheroo that I do. And so I get x is 10,000 divided by 2.83 ... So it's really divided by store 4. X, just remind yourself, how many decimal places do you need eventually, right? So x is a dollar amount. It's the dollar amount at each of these 3 payments. And so we'll only need 2 decimal places, but let's just write them all out just in case. So x, is going to be 10,000 divided by that, or recall 4 if you want. So I'll just do 1, 2, 3, 4, okay, 10,000 divided by recall 4 equals $3,531.45. I'm gonna try to remember that, 3531. So X is 3531.446, and then I lost it, 037. I like to have all my decimal places, or at least as many as are showing on my screen, just in case I round improperly, right? Then you can retain some marks if I see, oh, okay, well, it was just rounded incorrectly. Kind of not good to be rounding incorrectly, but better than some other mistakes that you can make. So as a dollar amount, 3531.45. Cool. So what we've found, right, is that at each of these time points, we would make payments of $3,531.45, right? But we would have paid more interest on the on the last payment than on the first payment, but that's all been adjusted for, right? And so the 3 equal payments, would be 3531.45 each. Good. Some other scenarios to consider are, okay, so in 6 months they make a payment, and then in a year they make twice that payment. Okay, what would change then? Then, if they make a payment in 6 months and then in a year they want to make twice that payment, you would have 2x. And then maybe they make a payment of 3 times the payment at 1.5 years, so then you would have 3x, which would just be used as your future value, but you solve them the exact same way that we just solved these. So some of the ways that this question could change, right, well, I could be calculating future values, right? What equal payments do I need to put away 6 months, a year, and 1.5 years from now? Time points can be different, right? But just to make it match, to have a total of 10,000 1.5 years from now, maybe 2 years from now, right? So you'll want to get really good at drawing your timelines and mapping out the question on your timeline. And then the timeline will tell you what calculations you need to do. So I know that's a big question to do. So let's just take a 5-minute break until 11:15. Yeah, so this is how you would do these payments. We're going to look at things like car loans and mortgages and kind of equal payment plans later, but the idea is the same. Yeah, awesome. So let's just take a quick break until 11:15. Stretch it out, shake it out. Okay, so these questions are really, really big, right? And so we actually don't get a lot of time to go through more options, but now I've shown you how to deal with kind of the 2 hardest question types from this section. So the first one was, okay, you've got an original repayment scheme and then they change their mind and then now you have a new repayment scheme, okay? That's the one type of question. And then let's call it new repayment scheme type of question, okay? The other type of question we could deal with that is quite kind of hefty here is the unknown payment amounts that we just solved for, right? Where we have to solve for X. What are these unknown payment amounts? And so this idea is how they figure out, so if you have a car loan, for example, your payments are always the same, right? But the further into time you go, the more you're paying off the principal versus the interest. And like I said, we're kind of parking lotting that until later, but that is what we're doing. The difference being that one, we have regular payments. So for a car loan or for a mortgage or something like that, then you have these regular payments, which we'll be talking about. But also we'll have compound interest. So not simple interest, but compound interest. So those are kind of, but we're building up towards that. So we're gonna get there, but we have to start down here with simple interest. Okay, so the last thing I want to talk about in this chapter is, 4.7 just gives a general outline of just how do you solve these problems in general. Of course, that's what we've been talking about this whole time, but it might be nice to have and maybe for you to review and just kind of see what's there, right? And so just 4.7 outlines general steps to solving simple interest problems. But first we make a timeline, right? And making a timeline sounds easy, but it's not. It's the hardest part of the question. The timeline is where we map out what we need to solve for, and then we solve it. Solving it is not that hard. The math is not hard, right? It's the figuring out what math we need to do that's hard, right? And so maybe review it, kind of see what's in 4.7. I think it's like just a quick, less than a page long of just kind of things to remember. What I do want to talk about 4.8, and usually, so I haven't taught this course online yet, but this is my first go, but I have taught it in person a lot. And so usually what I do is I put one of these questions that we're about to do on the test, thinking that it's going to be easy marks. And every term I think it's going to be easy marks for everyone. And then somehow people forget how to do these. So it's meant to be easy marks. And once we go through it, you'll see it should be easy marks. How come people aren't able to do it? I don't know. I think because it's at the end of the chapter and we roll on to something new and different, so then people forget about it. But just make a note that I do include a question like this on test 2. It's supposed to be easy marks. So 4.8 is when we have changing interest rates. So remember that example where we had, first we had, the rate was, I think, 9%, and then it changed to 7%, right? And so, and I said, well, we could have taken that 500 and had the interest rate changing, but then we would need what we're about to introduce here. So 4.8 is on changing interest rates. Okay. So from our formula sheet, from the simple interest section, now where are here, formula sheet, notice that we've worked a lot with this formula, right? The future value is P times 1 plus R times T. And the only thing we haven't talked about yet in this section is this kind of very similar but longer formula. So here we are. Now we're talking about this guy here. If we have a changing interest rate, so what this means is that for some amount of time, time 1, the rate will be R1. And then for some, so then it trades off. And so for some amount of time 2, the rate is R2. And then we allow for as many rate changes as we need. But in general, right, so the rate is R1 for T1 amount of time. And then R is R2 for T equals T2 amount of time. And then we just keep adding them together, right? And so for us, we capped it at R1 times T1, right? If you just have one rate, then you're back to where you started here, right? And so if the rate is constant, then you just have R1 and then the time that we've been dealing with already, right? And so this is just an extension of the formula that we have been using already. So notice this is just an extension of the future value is P times 1 plus R times T, right? Where R1 is just R and T1 is T because the rate is not changing. Because the rate did not change. All right, I just want to highlight that they're the same. Okay, so once we have the formula, there's really nothing going on here. Right now, we just need to say, okay, I need to figure out the amount of time that I'm at R1, and then the amount of time that I'm at R2, and then the amount of time that I'm at R3, et cetera, et cetera. And then I'll be able to find the future value, right? The total amount after these rate changes. So the last example on the examples handout that I posted. Kind of cute. The Yeti. Now I'm so used to the brand Yeti, which I think only spells it with one T, I think. Not 100%. But anyways, it doesn't matter. The Yeti has $2,000 to invest for 6 months. Okay, so the total investment is going to be 6 months. His bank pays 3.3% for the first 3 months, and then 3.5% for the remainder, which for 6 months, from 3 months to 6 months, is really saying for the next 3 months, right? So here, let's just outline that this is for the next 3 months. Okay. What amount will the Yeti have after 6 months? And so, right, our total investment term is 6 months, but now we've got this change in interest rate at the 3-month mark. So we want to find the future value. So, okay, I've got an R1 and a T1. So R1 is 0.033, making sure you have your decimals correct, right? So 3.3% is 0.033. And time 1 is still in years, right? So 3 months, 3 out of 12. And then here, R2 is 0.035. For the next 3 months, so T2 is also 3 out of 12. So now that I have this, right, I can map it out on a timeline, but it gets a little confusing because what does it look like? Well, it looks like, so here I am today, or the Yeti, I guess, and I've got 20,000 that I'm going to invest. And here at the 3 months, and then at the 6 months, I'm going to withdraw it. So what happens is I get this kind of R1 is 0.033 and T1 is 3 over 12. And then it trades off, right? So one thing that you could do is you could figure out kind of what this value would be. I don't want you to do that. I want you to use the formula. And so from here, it becomes some future value after R2, which is 0.035, and T2, which was also 3 over 12. So, and let me just, I'm going to bump this down so it's on the same, or all on the same page here. Make it line up. There. Yeah. All right. So now this future value, okay, is going to be, and I'm just going to use that formula, right? And so I just want you to use the formula. You don't actually need to do a timeline here because, like I said, it gets a little bit weird here at this transition point, right? And so the future value is P times 1 plus R1 T1 plus R2 T2. Okay, so what happens? Well, P is the 20,000. Wow, yeah, he's rich. So, right, whatever's on the left-hand side is always our P, and then whatever's on the right-hand side in the future is always our future value. So we have 20,000 times 1 plus 0.033 times 3 over 12 plus 0.0, oh, just wrote it weird, 0.035 also times 3 over 12. What you want to do, or what you need to do rather, is you need to simplify each of these R1 T1s individually before you add them up and add them to 1. Right? So you want to kind of order of operations this. So just showing each step, get 20,000 is 1 plus, I'm just going to do it on my calculator on the side here, 0.033 times 3 divided by 12 puts me at, and you might get some scientific notation on your calculator, not sure, 0.00825, let me just make sure, 1, 2, 3, only because mine shows up as in scientific notation. So it's saying 8.25 times 10 to the negative 3, so I just want to make sure 1, 2, 3. And then 0.035 times 3 divided by 12 is plus 0.0087. Now I can add up all these 1 plus 0.00825 plus 0.00875. I have to do that before I multiply by 20,000. So plus 0.00825 plus 1 means I'm at 20,000 times 1.017. Okay. So multiply this out. So multiply 1.017 by 20,000. Make sure I have enough zeros. Puts me at, 20,340 even, which is great because it's in minis. So Betty in 6 months would have $20,340 with these rate changes. Nice. So in 6 months, the Yeti will have $20,340. Nice. Okay. That's the end of simple interest. And a few weeks from now, yeah, I'll ask for a timeline. So I'll say, make sure you draw a timeline if I need a timeline. Okay. So I'll just make a note of that here. That's the end of this. So note, if a timeline is required, I will say so in the question. In the question on the test. For practice, it might be good to just get in the habit of drawing timelines just in case, but especially in this case where it gets a little wonky, like there's nothing really going on here, then you can probably skip it. But just in general, I'll tell you if I need to see a timeline. Okay, so what I want to do is I want to start. So that's the end of simple interest. And like oh yeah, that's what I was saying. 2 weeks from now, you're going to be like, simple interest, what? We've moved on from that. We don't really use it anymore. But it is kind of a stepping stone into the next type of problem, which is compound interest. So chapter 5, and what I want to do is, I know I'm kind of, we're towards the end of the day here, but I want to introduce some terminology, some notation, and just the idea of compound interest so that we can hit the ground running on Thursday. So chapter 5 is on compound interest. Okay. So let's just talk about the difference between compound interest versus simple interest. So simple interest, we deposited some amount and then it just sits there, and at the end it pays off the principal amount plus the interest, right? So that's our future value. So simple interest, let's just outline them here. Simple interest is, and let's talk about depositing an amount instead of borrowing an amount. That's such a downer, right? And so let's deposit some amount and then it grows, and then our future value is just that principal plus the interest. So an amount is deposited, and at the end of the term, the future value is the principal and the amount of interest. The future value is the principal plus the amount of interest. So that's what we've been doing so far, right? So that's simple interest. Now, the difference, and I've mentioned it before, compound interest, what happens is if you're compounding monthly, for example, and the question will tell you how often you're compounding. But say we're compounding monthly, then at the end of each month, then the bank goes in and says, oh, this month you earned this much in interest. So I'm actually gonna snowball that with your principal amount. And then for next month, you're gonna earn interest on the principal as well as the interest that you just earned, right? And so at the end of each month or at the end of each compounding period, the interest gets added on, and then you earn interest on the principal and the interest that you've just earned. So compound interest okay, so an amount is deposited, right? So an amount is deposited and will compound at some frequency monthly, just for this example. And at the end of each month, the amount of interest earned that month is added to the principal for the next month. Okay. So at the end of each month, in this case, the amount of interest earned that month is added to the principal for the next month. Okay, so at the end of each month, the amount of interest earned that month is added to the principal for the next month. For the next month. And so on and so forth, right? So you can see how it's compounding. So at each frequency, so at each compounding frequency, you're adding a little bit more money, okay? And so kind of visually what happens is, so visually, if you deposit amount of money today, let's say I deposit 10,000 today, okay, and I'm going to let it sit there for 3 months just for simplicity's sake, okay? But I'm compounding monthly, so compounding monthly. What that means is I get at each 1 month interval, then this 10,000, I'm going to find the future value, and then I'm going to use that future value as my principal for the next month. So I have 1 month, and 2 month marks. Okay. So what happens is, okay, so my total amount of time is 3 months, right? But then I'm compounding monthly. So this becomes some future value 1, which, right? So here after 1 month, I add on the interest, and that is the formula that we've been using, right? Future value 1, okay, so for this section, it's simple interest, right? Then this future value becomes my principal amount for the next month. And so this becomes P1 for the next month, which is going to give me, let's do this, future value 2, right? We're not going to draw our timelines like this, so don't worry, I just want to show you what's going on. Which becomes the principal amount 2 after the second month. And then from the second month to the third month, then I get to some future value 3. And so this, right, 10,000 grows to some final future value. Okay, so this is my final future value. Instead of doing these calculations, we have new formulas that we can use. So instead of doing these calculations, we revise our formulas. And I'm not going to derive them. I'm not going to show you where the new formulas came from. I'm just going to give them to you. We're going to use them, and don't worry about where they came from. But they do come from the simple interest, so we can build them up. But that's not what we're here for. We're here to use them. So instead of doing these calculations, we revise our formulas to take this compounding into account. To take the compounding into account. Okay. So if you go to your formula sheet, right now we're in the compound interest section. Okay. And so, right, because here, what's happening at each month, we're compounding our interest with our principal amount and making a new principal amount, right? So here we're compounding. Imagine that this was something weird, like you're compounding daily for a year. You don't want to draw that out. But you don't have to do that, right? Just ignore that. But so that's why we're not going to draw it like this either. I just wanted to show you what's going on. But on your formula sheet, now we're here, and it's the end of the first page. Can you believe it? So on our formula sheet, okay, without knowing what each of these items are, such as I and N, now we're using PB instead of P, but we've been calling it our present value anyways. So that's not that big of a change, but what's new here is I and N. But notice that you actually only need this first formula, this future value formula, and then it's been reworked to solve for P, B, I, and N. And that's just so that you're able to just jump in and use these formulas right away. Okay. And so here, and notice we only need the future value is the present value times 1 plus I to the power of N. Ignoring the variables for a little bit, then we could solve for the present value for I and for N, which are given on the formula sheet. Just to break down the formula sheet just slightly so it's not so scary, right? In your mind, just kind of ignore these three for now, because you could get those from this first one, right? I'm going to keep them on here because we're going to use them, but I just wanted to kind of break it down. Now, how much time do I have? I know I'm leaving it kind of cryptic by not defining I and N, for example, but I want to leave it for next day. But maybe what I'll do is I'll just define them, because that's about how much time I have. So note, instead of using P for the principal value, instead of using P for the principal or present value, slash present value, we now use PB instead. I'm not sure why that is, but that's just something. Okay, P is PB, you can use them interchangeably. That's fine. I is the periodic interest rate. I is the periodic interest rate. Yeah. Which, if you look at your formula sheet, I is defined as R over F. R is the annual interest rate, which we're used to seeing, and F is the compounding frequency. Okay. So, and I is R over F, and R is the annual rate, annual interest rate. That's the same as before. Same as before. And F is the compounding frequency. Compounding frequency. For example, if you're, and I should say compounding frequency per year. If you're compounding monthly, what's your F? Your F must be 12, right? So that is monthly means that F equals 12. And I'll give you a list of all the compounding frequencies that you have to know. Okay. And then N, right? The only kind of the next new thing that we have here is N is the number of compoundings. So remember, we were talking about time in years. N is the number of compoundings that we can do, and N is the time T in years times the compounding frequency. But I'll save that for next day, mostly because I want to keep it on one page here, but I'll review I as well, so don't worry. Okay, if you have any questions, let me know. Otherwise, we'll pick right back up on Thursday after our quiz. So just remember, and I'll post the quiz and make a note and all that fun stuff. But yeah, let me know if you have any questions. Otherwise, see you later.